All right, we've got another example problem here where we have to decide which Lewis structure of thiocyanate ion is the most dominant structure. Remember, to find the most dominant structure, we want to use the formal charges and pick the one that has formal charges as a whole that are closest to 0. And if there's a tie, we're going to break that tie by picking the one that puts the negative formal charge on the more electronegative atom. So let's look at this example. Start out by circling our atoms. And I'm going to draw a dot on each of the bonds. And remember, that's how we're going to decide our assigned electrons. All right, and we also need to think about the number of valence electrons. So to start out, for sulfur, sulfur has 6 valence electrons. Carbon's in group 14, so it has 4 valence electrons. And nitrogen is in group 15, so it has 5 valence electrons. Remember, this is our valence electrons. And then we want to determine the assigned electrons, which is those dots that I just drew. So for sulfur, it would be 1, 2, 3, 4, 5, 6, 7. Subtract that. For carbon, it's 1, 2, 3, 4. So minus 4. And for nitrogen, it's 1, 2, 3, 4, 5. So subtract 5. We get the difference, and that's going to give us our formal charge. 6 minus 7 is negative 1, 4 minus 4 is 0, 5 minus 5 is 0. So we have formal charges of negative 1, 0, and 0. We want to pick the structure that has the formal charges closest to 0 overall. All right, sulfur, carbon, and nitrogen again. Same number of valence electrons, 6, 4, and 5. Circle each of those atoms and find the number of assigned electrons. So sulfur has 1, 2, 3, 4, 5, 6 assigned electrons. Carbon has 1, 2, 3, 4 assigned electrons. And nitrogen has 1, 2, 3, 4, 5, 6 assigned electrons. So we have 0, 0, and negative 1. It's the same formal charge, actually, in this case, as the other one. So let's check this. Sulfur, carbon, nitrogen, 6, 4, and 5. 2, 3, 4, 5, 6. Then 7 for nitrogen. 1, 2, 3, 4 for carbon. And 1, 2, 3, 4, 5 for sulfur. So I have positive 1, 0, and negative 2. Okay, so it wants us to decide which is the most dominant structure and which is the least dominant. Well, right now I can tell you which one's least dominant because it's the one that has formal charges farther from 0. So this is the least dominant because it's got a formal charge of positive 1 and another one that has a negative 2, where the others are either 0s or negative 1. So now, how do we decide which is most dominant? Well, if we go back to our notes, if there's a tie, the negative formal charge is to be put on the more electronegative atom in the Lewis structure. That would give us the most favorable or the most dominant structure. So we just need to decide what's the most electronegative, nitrogen or sulfur. And we could look at the periodic table for this. You would find that nitrogen is in that top row. So nitrogen is the most electronegative element. So since nitrogen is the most electronegative element of the three, we want to pick the one that has a negative charge on nitrogen. That would be this one, okay, because the negative charge is on nitrogen. So this is the most favorable, the most dominant structure. Let's do another one. Based on the formal charges, decide which Lewis structure of carbonyl fluoride is the most dominant structure. So we want to find the most dominant structure based on the concept of formal charges. All right, let's circle our atoms. Put dots. We'll do the same thing with this one. All right, and we want to write down our elements. So we've got fluorine, carbon, and oxygen. Over here we have fluorine with a double bond, fluorine with a single bond, we have carbon, and we have oxygen. Okay, fluorine is in group 17, so it's got 7 valence electrons. We always do valence electrons minus assigned electrons to find the formal charge. Okay, so we have 7 valence electrons for fluorine. We've got 4 for carbon because it's in group 14, and oxygen's in group 16, so we have 6 valence electrons. All right, to find the assigned electrons on the first structure, I'm going to count my electrons for fluorine, and both of these are identical, so it's 1, 2, 3, 4, 5, 6, 7. 7 minus 7 is 0. For carbon, it's 1, 2, 3, 4. 4 minus 4 is 0. And for oxygen, I have 1, 2, 3, 4, 5, 6. 0. Okay, it looks like this is probably our most dominant structure because they're all 0. But let's check the other one. Okay, fluorine, I'm going to do 7 minus 1, 2, 3, 4, 5, 6. Positive 1. Okay, the other form of fluorine, the single bond, I have 1, 2, 3, 4, 5, 6, 7. 7 minus 7 is 0. For carbon, I have 1, 2, 3, 4. So 4 minus 4 is 0. And then oxygen, 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is negative 1. So I have a positive 1 and a negative 1 formal charge. That makes this less favorable. This is the most dominant structure. Right here. Now, formal charges can show us some limitations to the typical Lewis structure models. One of the limitations is odd electron molecules. So we want to choose, in the case of an odd number of electrons, it's kind of hard to choose which structure is going to be more favorable. Well, we want to do that using the concept of formal charges to explain the choice. So let's draw our circles and dots. All right, for nitrogen, then we have oxygen. Nitrogen is in group 15, and oxygen is in group 16. We're going to subtract the number of assigned electrons. For nitrogen, it's 1, 2, 3, 4, 5, 6. 5 minus 6 is negative 1. Over here, I'm going to count 1, 2, 3, 4, 5. 5 minus 5 is 0. Okay, and then over here I have 1, 2, 3, 4, 5. 6 minus 5 is positive 1. And then over here, I'm going to count 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. So this is the most favorable. Or you could say the most dominant, the most likely structure. Then we've also got incomplete octets, something like BF3. Which possible structure of BF3 is more favorable? we're going to use the concept of formal charges to explain. Now, if you didn't know about formal charges or which elements tend to form double bonds, you wouldn't know the answer to this. Formal charge helps us to answer it. Okay, so boron and fluorine. Fluorine has 7 valence electrons because it's in group 17. Boron is in group 13. It has 3 valence electrons. It's kind of a sloppy circle, but you get the idea. Okay, I've got 1, 2, 3 for boron. That's 0. And for fluorine, I have 1, 2, 3, 4, 5, 6, 7. For each of them, it would be the same. 7 minus 7 equals 0. Now let's look at the other form. So I have boron and fluorine. All right, boron has 1, 2, 3, 4 assigned. Remember, it's got 3 valence electrons, minus 4. That gives us -1. And then for fluorine, I've got fluorine with a single bond, and I've got another fluorine that has a double bond. We've got to count both of them. Our single bonds are 7 minus 1, 2, 3, 4, 5, 6, 7. 7 minus 7, which would just be 0. And then the double bond has 1, 2, 3, 4, 5, 6. So it's going to be 7 minus 6, which is +1. And you can see that this is the structure that has a formal charge of 0. So this is the most favorable, or the most dominant or prominent structure. Again, you wouldn't necessarily assume that by looking at it, but boron, because it can be satisfied with just 6 valence electrons, and because of our formal charges, this is the most favorable structure. Note that BF3 often reacts strongly with compounds which have unshared pair of electrons and can be used to form a bond with boron. Something like this, like NH3 can react with BF3 to form NBH3F3. Then we've got one more, the expanded octet. We want to choose which possible structure of XeF4 is more favorable, using the concept again of formal charges. So let's look at it. Xe is in group 18, it has 8 valence electrons. And then we have F, it's in group 17, it's got 7 valence electrons. Here Xe has 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 8 is 0. And then fluorine has 7 valence electrons and 1, 2, 3, 4, 5, 6, 7 assigned electrons. So 7 minus 7 gives us 0. Therefore, this is going to be the more favored. But let's go ahead and check the other one. Xe has 8 minus, we're going to find how many. Then we have F with a single bond, 7 minus some number. And then F with a double bond is going to be 7 minus some number. Let's circle them and find out what they are. So for fluorine with a double bond, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 7 minus 8 is -1. For fluorine with a single bond, it's 1, 2, 3, 4, 5, 6, 7. 7 minus 7 is 0. And then for Xe, we have 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, 6. 8 minus 6 equals +2. Our formal charges are not 0 on the right, but they are on the left. That makes this the more favorable structure because we have formal charges of 0. That's it for formal charges, which also sums up our notes that covered resonance and formal charges. Spend the remainder of class working through some practice problems.